LeetCode problem 2235. Add two integers. Might sound like a dip in the kiddie pool, but don't be fooled. This kind of basic arithmetic shows up in embedded systems, low-level code, even cryptography, where you might not have access to high-level operators. And when performance is critical, even a tiny operation like addition deserves attention. So how do we go from waddling with loops to flying at machine speed? Let's ease in with the most literal approach, brute force. What if we think of addition as repeatedly stepping forward or backward? First, we check if the second number is positive. That tells us how many times we need to increment the first number to simulate the total. If it is, we loop that many times and bump the first number up by 1 on each pass, climbing our way to the sum. But if the second number's 0 or negative, we pivot. This time, we'll decrement instead to reflect subtraction. For a negative value, we loop through its absolute value and subtract 1 each time to simulate the downward steps. Once we've adjusted the first number through all the increments or decrements, we return it as our final answer. This runs in big O of absolute num2, so adding or subtracting 10,000 means 10,000 operations. Space is constant, but for large numbers, this ducky approach wears itself out. Let's shake off the flapping and fly smarter. What if we do addition the way computers really do, bit by bit, with no plus in sight? We'll use a loop that continues while there's a carry left to handle. That keeps the process going until every bit is resolved. To find carry bits, we apply Bitwise and. Wherever both bits are 1, we know a carry needs to happen. Then we use XOR to add the numbers without carry. This gives the raw bit sum, ignoring any overlaps for now. Next, we shift the carry left by 1, moving it up to the next higher bit, just like in manual addition. Once all carries are absorbed, the first number holds the complete result, sum and all. This takes constant time big O of 1 since Java integers are 32 bits. Just a few variables blazing fast. It's clever and efficient, though maybe not the most readable option out there. Alright, let's simplify. After simulating and mimicking CPU logic, what happens if we just add them? We define a method that takes two integer parameters, our inputs for the addition. And now we simply return their sum. No tricks, no checks, just clean and direct. This method runs in constant time and space, big O of 1. One CPU instruction, no matter how large the numbers. That's why it's the go-to in interviews. Clean, scalable, and instantly understandable. So what did we learn from paddling through LeetCode 2235? The brute force ducky approach mimics the process, but tires quickly at big O of absolute num2. The Bitwise method is sharp and efficient, matching how hardware adds, but trickier to read. And the direct addition? That's the golden egg. Fast, clear, and perfect for interviews. Why does it matter? Because writing great code isn't just about speed. It's about knowing when to optimize and when to keep it simple. So ask yourself, how would you solve this without the plus? And where else can Bitwise tools give you an edge? Keep diving in. Your instincts will thank you.